Here's just a few examples of multiplying radicals. Radicals follow the same rules as exponents, since actually that's really what they are. So if they have the same radical or the same exponent, you can multiply them no problem. But if they're different, this one not having a radical and this one having a radical, you cannot multiply them. So here we have the square root of 3 times the square root of 7, which is equal to the square root of 21. But 5 times the square root of 3 is just 5 times the square root of 3. We can't do anything there since they're not the same. They both have to be inside, have the same radical in order to multiply them. Similarly, we can split them up in the same way we multiply. So here we have the square root of 3 times the square root of 7 is the square root of 21. The square root of 20 we can break back up as the square root of 4 times the square root of 5. And the reason we might want to do that is because we can take the square root of 4. The square root of 4 is 2. So now we're left with 2 times the square root of 5, which gives us a little bit of a better idea about how close that number is. It's closer to 2 here. The square root of 20 gives us kind of less of an idea about the value of that number. I could have obviously broken up 20 into the square root of 2 times the square root of 10, but I wouldn't have been able to simplify anything there. So the reason I had picked 4 was because I could take the square root of 4. So when you're asked to simplify a radical, this would be the simplest version.